Welcome, peoples of the internet. We have today is the OnGuard bike lock fix. And when I say fix, what I'm talking about is I got a couple of these OnGuard bike locks. You can get them off Amazon for like 20 bucks. I don't know if they make the exact same type, but here's the thing. So this one's not broken, and the part that I'm talking about here is the mounting lug, which is this little guy here. Now on this one broke off, and it broke off pretty easily. And if you look at the broken part, you can see sort of just how bad a design this is. What you have here is this is the lock, and this is what mounts it onto your bicycle, your handlebars, or wherever. It goes in and then it rotates and then locks in place. And on the receiving part, there's a little lever that you push and then you can rotate and pop it out. And that's all well and good, except if you look at this, I don't know if you can see just sort of how thin the thickness of this is. It's pretty thin. Now, it was mounted on here like this. Of course, they don't sell a replacement for it, because even if they did, how would you get it on? This part is sort of, this is part of the lock. There's no way to get the thing on, even if you did have a replacement for it. So, if you break this, well, then you go back to the old way you did back in the 80s, 90s, early 2000s, whenever, where you have this wrapped around some portion of your bike. And that's fine, I guess, but it could be a lot better. So what this is made of is there's actually three parts. The bike lock, which is the cable, which is where this affixes to. The mounting lug portion, and a screw. There's a screw that goes through here and clips onto this thing over here, and actually screws into this over here. So, wow, this is such a terrible design. The more you look at it, the worse it gets. They know that this goes in and then rotates in order to lock. So the amount of force and torque that you're placing on this is going to be right up all in here around this tubular piece. And there's no reason for them to make this as thin as they made this. I mean, it's just really, this is just a really bad design. So when you look at something and you say, well, something is good engineering or bad engineering, what's someone talking about? They're talking about this kind of thing, where they've manufactured a significant engineering defect, meaning that, like in this case, it would be this plastic being so thin, into a part that's really, it's foreseeable that this is going to have torque stress placed on it, right? If you didn't press the little lever on the thing right and you're placing a lot of torque on it, you're going to break something, and it's going to be this little guy, no question about it. I mean, could you break the mounting piece or the little lever inside the mounting piece that actually goes on the bike? Yeah, you could. They're all pretty fragile pieces, but the fact that they under-engineered this so much, I mean, all they had to do was double, triple this, and you would have had a part that was really 10 times stronger. Now, to replace this, I'm going to 3D print it. I'm going to design it in my software, and there's probably a dozen different types of software that you can use, so that'll be up to you to figure out what works best for you. Maybe I'll throw this on Thingiverse. But one of the things that I'm going to fix in my design, obviously I have to copy the basic shape, right? You've got sort of a rectangle, you've got these little knocked off edges over here that allow this to go in and then rotate very easily. So that's why they've sort of knocked off the edges right there and over there, because this is what's going to be doing the turning portion. It turns in a clockwise way. When it locks, it's a 90-degree rotation, goes in and rotates. But the thing that I'm going to change is, so I'm going to make this into two pieces. And obviously a bottom piece, which is half the circle, and then a top piece which screws onto this. And the more I look at it, there's no reason that they shouldn't have done this. In fact, they should sell that as a replacement piece. So, yeah, wow. And of course, I'm going to definitely beef mine up. And I'm going to put recesses on mine because mine's going to have 2 screws or more in it, 2 on each side maybe, to hold the top portion to this bottom portion, or what'll be the bottom portion. And I'm going to retain the screw that keeps it from moving back and forth on the actual cable. That's fine. But yeah, this could have been done so much better right from the start. And they could have done it in a way such that it could be put on before or after the manufacture. The way they've got it set up right now, the only way you can put this on in the one-piece format is before this is actually manufactured. And by breaking this, which is, again, this is incredibly fragile, when this breaks, you kind of lose the nice feature of the entire lock, whereby it locks onto the bike with its own little holder. So anyway, we're going to repair this with a 3D printed one, and hopefully the 3D printed one will be stronger and more robust. Now, I'm not using anything special. This is going to be on my longer orange 3D printer, and this is just about, the right size for something like this. It's a small part. It'll be in 2 pieces. I'm going to do it in metric, not English. Not that that matters, but that's how I'm going to measure everything. So we'll go to the printing and the design. With my software, of course, you got to design everything first on paper and then import it in, because just doing it like a sketch doesn't work. Again, these dimensions for this little thing, for this locking lug, this T piece, as we'll call it, this T cam piece, are critical. The rest of it's not. So that gives us a lot of room to play around. I don't want to make this too high, the stem portion of the T, because if I do, it'll be subjected to various forces again, which will act on it in a bad way. So, all right, on to the 3D CAD drawings and the importing it into the resin printer. Okay, so here we are. I've taken some notes, and I've done a couple of quick drawings and made some measurements, and this is what I've sort of come up with. And I'll go through the thought process with you here as we do this. So first we've got the locking lug, which is over here. Now obviously this has to maintain its dimensions in order to fit on the bike where it came from. So we've got our original dimensions. I've put in some, again, this is just a crappy sketch. Nothing's to scale here. I mean, this is the actual piece right here. I like to use, these calipers. I think they're pretty good. You can use anything. I also like to keep things in one of these books that I have with all my sketches and inventions and stuff. Any piece of paper, scrap paper, maybe a cocktail napkin will work for this. You don't really need much, but you do need, if you're going to put this into a CAD program, which is then going to go onto a 3D printer, you are going to need, you're going to need to know the dimensions. But anyway, so this is sort of the thought process on how I went through this. So obviously the first part of this is just the dimensions, finding out what we have, because I'm going to need those to put into the program. And then I talk about my new design over here, keeping the original mounting lug dimensions, but we're improving on the design by incorporating a thicker cable support wall. I measured the cable. Cable's 10 inches diameter, and a 2-piece design. And I noticed, this is basically kind of like your typical rifle scope mounts. So if you have the scope, and then you have the gun, and the thing that holds the scope to the gun are the rings, or the scope rings, or the mounts. Well, anyway, this is basically the same idea. You've got screws that go through and lock it together. I actually drew this wrong. So when I was drawing this, I put this in almost as a side view, and this doesn't really go that way if you turn this way. as you can see, you don't have those projections out. So it's kind of funny. As you're messing around, you sort of see, gee, what am I doing? And here the new design, we've got the flanges that stick out here and here. So there's a screw here, screw here, screw there. On the underside, we're going to put in a recess for a little hex nut. I don't know if that's going to be like a 3mm or whatever, a really small little hex nut. I've got some little tiny screws I'm going to use for this. And that's there. Now, when I originally did this, I came up with a 3mm wall thickness. And I said 3mm should be pretty thick, because when I measured this is like 1.5 millimeters. I'd be doubling it. Well, this isn't the same thickness all the way through. So when I added up the thicknesses, the flange thickness, and everything else, it came out to around 16mm. Well, when I put this out with 16mm, I'll throw out 16mm. You can see what I'm talking about here. It made me step back. There we go. We'll get it to 16. And it made me say, gee whiz, this really isn't that much beefier. And that would be with the flanges on it. So what am I doing wrong here? What am I miscalculating for? Well, I went through and I remeasured these thickness over here, and it gets thicker as you go in. So it's very deceptive. So then I said, all right, we're not going to do 16. 16 is not going to work. That 3mm wall thickness needs to be bigger. So then I did the calculations over here, and I figured out, all right, with a 4mm wall thickness, we're going to get to 18mm overall. If I move it up to a 5mm wall thickness, which is pretty beefy, then we're going to get to 20 overall. Now, I'd rather over-engineer it than under-engineer it, because obviously the original was under-engineered. One of the other things I made about the notes was you have these little areas over here. I'm not going to actually design this in. This little knockoff area, and I don't know if you can see that on here, but there's a little knocked off areas here to help it cam. Well, those knockoffs, I'm just going to hit that with a file to do that. Now, there is a detent, which is on the underside of this. Again, I don't know if you could see that. And that detent mates with little spring things. It's very, very, very shallow. I'm not sure if I'm going to be able to properly capture it, because it's maybe 3mm wide, maybe 1 millimeter. It's very hard to measure. Millimeter in total depth. So I'm gonna put it into the drawing, and you'll see it on the computer. I don't know if it's going to translate into the 3D print. Now, this is all trial and error. This may not work. So, you do your best. You go back and forth. You try to figure out what's going to work, what's not going to work. You don't know. Calipers. I also have, by the way, I have a bunch of digital stuff. So I've got micrometers and things like that. But for something like this, these calipers are fine. And I'm sure you could probably wing it with something less fancy. And again, this is just so that I have numbers to put in. This isn't getting patented. This isn't going to the patent office or anything like that. It doesn't have to be any fancy drawings with India ink on Bristol board. Just dated myself. Sorry, Internet. But anyway, so this is just sort of explaining the thought process. And you have something like the 16, and you go back and say, you know what, 16, that's not good enough. That's not going to work. So let's go to the 20mm overall, and maybe that's going to be too much. Maybe it won't be enough. I don't know, but we don't know until we try. So okay, on to the computer. Okay, so this is the base portion drawn in the CAD program. I'm not even going to go into how I did this, because that's actually worthy of an entire different video, and because there are dozens, literally dozens of different types of 3D CAD software out there, it would be ridiculous for me to go do this, because if you're not using the same thing that I'm using, and you're using Blender or using Fusion, it's all going to be different. So anyway, I'm just showing you this. This is the base. Now, I don't know if this is going to work or not. I don't know if it's going to print right, and if it does print properly, I don't know if it's going to fail or not. This is a prototype. So, is it exactly what I drew? No. I am not a drafts person, expert guy. So I am sort of muddling my way through this with this program. And, could it fail over here? Probably. Could it fail here? Could it crack along here? Sure. Could these, hex things break? Yeah. Could the material just not be strong enough for the implementation? Could these detents over here cause this whole thing to fail? Is this wall going to be too thin? I have no idea. This is a prototype, so it is what it is. In fact, I would be surprised if it didn't fail. But hopefully when it does fail, I will learn more and I'll be able to correct the failure points. And if it's a material issue where you just can't make one of these things out of the 3D SLA material, well, oh well, nothing I can do about that at this point. Maybe I can send it out and have it made out of metal or something. Of course, then when I do, this piece will be so strong that it'll end up breaking the base plate that it mounts into. So, yeah, you're damned if you do, and you're damned if you don't. So, anyway, on to the 3D printing, and we'll take a look at how that's coming. Okay, so this is the printer, and there's a little picture of it. And as I pull back, you can see it is in the goo over here. And we have, what does it say, 2 hours and 18 minutes. And there's a little picture of it. This is the longer, orange or whatever it is printer. I think I got it for $180. They had some kind of deal. And yeah, so without making you watch this for 2 hours and 18 minutes, we're just going to jump ahead. And you'll see the finished product after I rip off all the material, the legs and stuff that are on these things, these little support material things, and clean it up. And then we will try to do a test fit on the actual bike mating mechanism. So, without any further ado, okay, so after these things come out of the printer, and I neglected to show this before, one of the things I do, they say you should do, is expose it to UV light. Now you can put it out in your outside on a windowsill or something like that, or you can get one of these little lights like I got from Amazon. I think I paid like $15-20 for it, something like that. And there it is, lo and behold. And what I do is I let this sit under here for 5-10 minutes. I'll rotate the parts around or whatever. And that will harden up the resin, give it a nice hardness. Now, the difference between the original material and this material is not nearly as hard as the original material. And there's no way to make it that hard. It's just a different material. So, and how do I know that? So I took a file and I put the file against some hardened material that I had laying around for this stuff, and the file against the plastic material that came from the factory on the part that we're replacing. And the part that we're replacing is definitely a harder part. Now, nothing I can do about that. What would be one fix? Well, I could replace, say, this lug. I could remove this lug and mill it out and put in a piece of brass, which I could machine to fit this. The problem is that then the failure point would definitely be the receptacle that mounts into, because brass, even though it's a soft metal, is still much harder than plastic, and the brass would I'm sure if it failed, it would break the plastic, and the plastic would be the failure point if the whole unit failed. So anyway, yeah, we're going to keep this as plastic and do the best we can with it. As you can see, this is really satisfying. I opened this up about 1/2 millimeter in the drawings, and this just popped right in. So the other 3 will pop right in as well, I am sure. And boy, just popping that right in, the snugness of it and the feeling of it going in is just ridiculously satisfying. Okay, so this is it. I have installed it. Now I'm using 3mm by 12mm length screws on the unit here. That's what works for this. And now we're going to go test this out and see if it works. Okay, we're going back to the bicycle. Now, one of the things about this is this is a substantially heavy lock. So you have the weight of this always sort of weighing down. So I may have to reevaluate my placement of the receptacle, because it may not be that great of an idea to have this much weight sort of hanging off on an arm, creating a moment about the point. But okay, here's the test. This is our second one, I guess. And let's see if it locks down the way it's supposed to. It goes in. Okay. And yes, there we go. There's that sound, that click sound that we were waiting for. Yes. All right. I hope you heard the click over there. I'm going to release this over here and turn it, take it out, and we'll try it again. We'll try it from a different angle just to see if it works from the other side as well. If for whatever reason it worked on that side, it should work on this. Yes, that's the sound. All right, so this seems to hold. Hopefully this weight isn't too much that it's going to snap that lug off. Don't know how to abate that. It's a question, I suppose. Have to figure something out. Anyway, very, very happy. This clicks and locks in place, and it's on there. This isn't going anywhere. I could probably lift up the bike. I'm not going to do it. There's too much junk around me over here in the garage. But this is a pretty amazing thing. I'm pretty pleased with this and the way that it worked. And I am even more pleased that I only had to do 2 iterations of this in order to get a working prototype. Now, does this mean this thing won't break? No. This may break the first day I'm out, or it may hold up. And I'm going to say about putting the STL files on Thingiverse with a note that you may have to do a little sanding and filing, because it's more of a fitted fit. It's not just going to be perfect as it comes out of the machine, although maybe, I don't know. But I am really, really happy. It's on here. And it's got room to play, so it's not binding up or anything. And if I hit the little switch on the side here, let's see, I can rotate this out just like that. It rotates out just fine. Look at the bottom. Doesn't seem to be chewed up or mangled in any way. That's always a good sign. So I am considering today, click, a success. Happy day. All right. Is this going to get in the way of my shifter? Probably. Maybe I should use some Velcro around here just to keep it out of the way, or maybe I should reposition this to another place. I don't know. Not like I was going riding anyway. It's been raining for the past couple of days. So thank you, people of the internet. Cheers, and I hope you like this video. All right, the moment of truth that we've all been waiting for here. Let's see if our fixed dimensional thing that we've been working on here actually does what's supposed to place in here. Flip the little switch with my finger. I don't know if this, I'm switching. I'm pushing on this, by the way. This is the lever that I'm pushing. That's my kid inside making noises. If you hear that. Oh wow, that is perfect. Wow, that's really good. Okay, so now to finish printing out the top piece and to mount it onto the actual bike lock and finish this project. Thank you.